Hello students, welcome to the second video of a complex number class. First we start Brahmanath. Shanti Shanti Shanti. Susta. Today we will discuss some other part of the complex number. Last class we are already discussed what are the algebra of a complex number, like that addition, subtraction, multiplication and division, and what is imaginary number and a complex number. You know, complex number means sum of real number and imaginary number is known as a complex number, and this complex number is denoted by small letter z, that is z equal to a plus ib, where a and b are real numbers, but a is called real part of z and b is called imaginary part of z. So if b equal to 0, then z equal to a, which is purely real. If a equal to 0, then z equal to ib, which is a purely imaginary number. So every imaginary number is a complex number whose real part is 0, and every real number is also a complex number whose imaginary part is 0. There is no order relation in the complex number. Okay, so complex number re को number ta greater hobo, को number ta smaller hobo, we cannot able to say which one is greater and which one is smaller. Okay, there is no order relation in a complex number. So last class we are already discussed how to find the addition, subtraction, multiplication and division, but today we will discuss reciprocal of the complex number and equality of the complex number. You know, reciprocal of the complex number. First we discuss reciprocal of a complex number. Reciprocal is also known as multiplicative inverse of the complex number. Let z equal to a plus ib be a non-zero complex number, be a non-zero complex number then reciprocal of z, reciprocal or multiplicative inverse or multiplicative inverse of z is denoted by 1 by z. 1 by z is not a complex number. Okay, so 1 by z equal to 1 by a plus ib, and this is 1 a minus ib, here a plus ib into a minus ib. तो यार रेसिप्रोकल हमें conjugate मल्टीप्लाई करवा ना कि this is a minus ib by a plus ib into a minus ib, a square minus ib रो whole square, and this is a minus ib by a square minus I square into b square, but I square equal to minus 1, and this is a minus ib a square plus b square because I square equal to minus 1, and this is a by a square plus b square plus minus b into I by a square plus b square, which is a plus ib form. So multiplicative inverse of z equal to a plus ib is real part of z by real part of z square plus imaginary part of z square, plus minus b into I by real part of z square plus imaginary part of z square, and this is known as reciprocal of the complex number. तो z रे ऊपर -1 z इनवर्स, दिस इज a by a square plus b square plus minus b by a square plus b square. Okay, for example, find multiplicative inverse, find multiplicative of z where z equal to 3 plus 4i. You can apply the formula, that is z multiplicative of z equal to 1 by z, answer. So z inverse, this is 1 by z equal to a by a square plus b square, here a is 3 and b is 4, so 3 by 3 square plus 4 square plus I times minus b plus I times minus b means minus 4 by 3 square plus 4 square. Okay, so this is 3 by 5, 3 by 25 plus I into minus 4 by 25. Okay, this is the multiplicative inverse of z equal to 3 plus 4i. So in this way you have to find the reciprocal of the complex number. Okay, next we find equality of the complex number. Equality of a complex number. So two complex numbers z1 equal to a plus ib and z2 equal to c plus id are said to be equal if they have same real and imaginary parts. Okay, so real part dira complex number equal thibo and imaginary part dira equal thibo, then we say two complex numbers are equal. That is z1 equal to z2 if a equal to c and b equal to d. देखो a होची रियल पार्ट ऑफ z1 और c होची रियल पार्ट ऑफ z2, b होची इमेजिनरी पार्ट ऑफ z1 and d होची इमेजिनरी पार्ट ऑफ z2. So z1 equal to z2 means a equal to c and b equal to d. Okay, for example, 2 plus 3i is not equal to 3 plus 2i because they have not same real part and imaginary part. They have not same real part and imaginary part. Okay, 1 plus I is not equal to also I plus 1 because here real part 1 nahi, they are equal. 1 plus I equal to I plus 1. देखो रियल पार्ट 1 अच्छी, ए रियल पार्ट 1 अच्छी, इमेजिनरी पार्ट 1, ए भी इमेजिनरी पार्ट 1 अच्छी. 1 minus 2i equal to 1 plus 2i, not equal to 1 minus 2i is not equal to 1 plus 2i. कहीं रियल पार्ट 1 अच्छी, या रियल पार्ट भी 1 किंतु इमेजिनरी पार्ट -2 अच्छी, बट हियर इमेजिनरी पार्ट +2, दीटा पार्ट सेम रहा अच्छी. Real part equal to appudu, imaginary part equal to varu. Okay, then we say these two complex numbers are equal. Now one question, for example, find x and y if now find x and y if 3x minus 7 plus 2iy equal to minus 5y plus 5 plus x. Okay, so to find x and y by equality of these two complex number, so how can you test two complex numbers are equal if they have the same real part and imaginary part? So answer 1. देखो here 3x minus 7 plus 2iy equal to minus 5y plus 5 plus x into y. So here the left hand side, this is a complex number form which is a plus ib form. This is also a plus ib form. Here real part is 3x minus 7 and imaginary part is 2i. ये रियल पार्ट इज माइनस 5y and imaginary part is 5 plus x. So answer 1, 3x minus 7 plus 2yi equal to minus 5y plus 5 plus x into I. That implied 3x minus 7 equal to minus 5y and 2y equal to 5 plus x. Okay, that implied 3x plus 5y equal to 7 and 2y, that means x minus 2y, x minus 2y equal to minus 5, minus 2y equal to minus 5. Okay, so here 3x plus 5y equal to 7, x minus 2y equal to minus 5. ये आम कौन करिया 2 मल्टीप्लाई करिया ना कि ये सो ये आम 2 मल्टीप्लाई करदेव दैट इम्प्लाइड हियर 3x प्लस 5y इक्वल टू 7 हियर 3 मल्टीप्लाई कर बाय इक्वेटिंग कोएफिशिएंट ना कि ये 3x अच्छे ना ये x अच्छे आम 3x मल्टीप्लाई कर 3x माइनस 6y इक्वल टू माइनस 15. सो माइनस प्लस प्लस है तो प्लस 3x माइनस 3x कैंसल. Here 5y plus 6y, this is 11y, 11y. Here 15 plus 7, 22. This is 22, that implies y is equal to 2. Now substitute the value of y in that equation. Here x minus 2y, x minus 2y equal to minus 5. So x minus 2y, y means 2, 2 into 2, 4 equal to minus 5. So x equal to minus 5 plus 4, that is x equal to minus 1. Therefore x equal to minus 1 and y equal to 2. These are the value of x and y. Okay. तेणु दीटा कम्प्लेक्स नंबर को इक्वेटिंग करी तुम एक्स वाई वैल्यू बाहर करिया गले फास्ट दीटा कम्प्लेक्स नंबर को स्टैंडर्ड फॉर्म आनिया कन्वर्ट करिया पड़ो ए प्लस आई बी फॉर्म को तापर इक्वेटिंग करिवो रियल एंड इमेजिन पार्ट. ओके, so equating real and imaginary part to find the value of x and y. Number 1. Number 2, answer 2. Answer. So answer 2, 1 minus I into x plus 1 plus I into y. 1 minus I into x plus 1 plus I whole into y equal to 1 minus 3i. So 1 minus I into x अच्छी. This is not in a plus ib form. First of all you have to convert a plus ib form. देखो, now multiplying this one, x minus I into x plus y plus iy equal to 1 minus 3i. That implied x plus y plus I times minus x plus y equal to 1 minus 3i. Here left hand side is a plus ib form, right hand side is also a plus ib form. Now equating real and imaginary part, equating real and imaginary part, x plus y equal to 1, then minus x plus y equal to minus 3. Okay, now 2y equal to minus 2, that implied y equal to minus 1. So x plus y equal to 1, x y means minus y equal to 1, that implied x equal to 2. So x equal to 2 and y equal to minus 1. Okay, answer 3 देखो, answer 3. So here x plus iy into 2 minus 3i equal to 4 plus I. LHS is not a plus ib form. First you have to make a plus ib form by multiplying this one, x plus iy into 2 minus 3i. 2 minus 3i equal to 4 plus I. देखो, now multiply this one, x into 2, 2x minus 3xi plus 2yi minus 6 minus 6yi square. Okay, iy into minus 3i means minus 6y I square equal to 4 plus I. 4 plus I, that implied here 2x minus 3xi plus 2yi. I square means minus 1. Minus 1 into minus plus है ना, तो 6y equal to 4 plus I है ना. Now 2x plus 6y, 2x plus 6y taking I common, minus 3x plus 2y equal to 4 plus I. तो फास्ट तुम a plus ib फॉर्म कन्वर्ट करिया पड़े, तापर से a कोटिंग करियो ना. e कोटिंग रियल एंड इमेजिनरी पार्ट वी गेट 2x plus 6y equal to 4 and minus 3x plus 2y equal to 1. तो आर इमेजिनरी पार्ट minus 3x plus 2y अच्छी, यार इमेजिनरी पार्ट इज 1. ओके, नाउ एटी कौन करा हबो, मल्टीप्लाई कर दियो, 2 मल्टीप्लाई 2 कॉमन नहीं जो, तो x plus 3y equal to 2. okay, x plus 3y equal to 2. here minus 3x plus 2y equal to 1. अच्छा, so write these two equation, x plus 3y equal to 2, next minus 3x plus 2y equal to 1. okay, so ये हमें कौन करा हबो, मल्टीप्लाई कर दियो 3 रे, 3 रे मल्टीप्लाई करले x रो कोएफिशिएंट इक्वल हो जिवो, दैट इंप्लाइड 3x plus 9y equal to 6. here minus 3x plus 2y equal to 1. now cancel by adding these two equation. so here 9y plus 2y 11y equal to 7, that implies y equal to 7 by 11. okay, substitute this value, x plus 3y equal to 2, x plus y means 7 by 11, so 21 by 11, 3 into 7 by 11, so 7 3 21 by 11 equal to 2, that implied x equal to 2 minus 21 by 11, 11 into 2 22, so 22 minus 21, so 1 by 11, therefore x equal to 1 by 11 and y equal to 7 by 11. x equal to 1 by 11 comma y equal to 7 by 11. okay, next number 4 देखो, number 4 टा भी हमें सॉल्व करिबा. okay, answer 4, first we convert the LHS part into a plus ib form. तेणु इक्वटिंग करिया पूर्व दुईटाक पार्ट को आम a plus ib form कन्वर्ट करिया पड़ियो. here LHS part is not in a plus ib form, so by simplifying to make a plus ib form, first we take LCM. here LCM ले जो 3 plus I into 3 minus I, x minus 1 into 3 minus I plus y minus 1 into 3 plus I equal to I. That implied, multiply this one, 3x minus ix minus 3 plus I plus 3y plus iy minus 3 minus I whole by 3 square minus I square equal to I. That implied 3x, here 3x real रखो, 3x plus 3y, 3x plus 3y. okay, all the real number into one box, सब जगह रियल नंबर को गोटे बॉक्स भीतर रख. 3x plus 3y, यार -3 केते होची -6 plus I taking common minus x plus y, here plus I and minus I both are cancel. okay, तो minus x plus y whole by 3 square 9, I square means minus 1, तो plus 1 है equal to I. okay, do you understand? So first you have to make a plus ib form into LHS also RHS side. So 3x plus 3y minus 6 here plus I into minus x plus y equal to 10i. Now equating real and imaginary part, we get here real part is 3x plus 3y plus 6 and imaginary part is minus x plus y. In the right hand side real part is 0 and imaginary part is 10. So 3x plus 3y minus 6 equal to 0 minus x plus y equal to 10. Okay, minus x plus y equal to 10. Now you are taking common 3, that implied x plus y minus 2 equal to 0. Here minus x plus y equal to 10. Here that is minus x plus y equal to 10 and x plus y minus 2 equal to 0 equal to 2 है ना. अच्छा, x plus y minus 2 that is a plus 2 equal to 0. That 2y equal to 12, that implied y equal to 6 and minus x plus y equal to 10, substitute the value of y. So minus x plus 6 equal to 10 है. So minus x equal to 4, that implied x equal to minus 4. So x equal to minus 4 and y equal to 6, therefore x equal to minus 4 and y equal to 6. These are the values of x and y. Okay, तेणु दीटा कम्प्लेक्स नंबर को इक्वेटिंग करिया गले फास्ट तमे ए प्लस आई बी फॉर्म ट्रांसफर करिया पड़ो बोथ पार्ट को, तापर इक्वेटिंग करी वैल्यूटा बाहर कर. Conjugate of a complex number. Okay, so let z equal to a plus ib be a complex number. Let z equal to a plus ib, where a and b are two real number, be a complex number, then conjugate of z is denoted by z bar. Read as bar, z bar, where z bar equal to a minus ib. If z equal to a plus ib, then z bar will be a minus ib, which is obtained same in real part, but opposite sign in imaginary part. Okay, so how can you obtain the conjugate of a complex number? You have to make real part same but change in opposite sign of imaginary part. तो real part को same करिवो, imaginary part रो sign टा change करले जो complex number आसीबो, that is known as conjugate of a complex number. For example, 3 plus 4i रो conjugate 3 minus 4i, केवल imaginary part टा को change करियो, plus ले minus ले plus. Number 2, minus 1 minus 5i रो conjugate, this is minus 1 plus 5i, Number 3, 3i रो conjugate, this is minus 3i. Number 4, 2 रो conjugate, this is 2, kind of real अच्छे ना, so every real number is a complex number. So 2 bar is equal to 2. If a complex number is purely real, then z equal to z bar. If a complex number is purely imaginary, then z bar equal to minus z. 0 conjugate कौन आसियो? 0. 0 conjugate, this is 0. Okay. So conjugate आसियो means r after conjugate जब लंबो, you will get 3 plus 4i. That means z conjugate equal to z. So in this way you have to find the complex number, it's a conjugate. Okay. What are the properties of conjugate complex number? Properties. Properties of conjugate complex number. Properties of conjugate na here you need a conjugate. If z, z1 and z2 are complex numbers, these are the complex numbers, then number 1 z conjugate then z bar equal to z. So if a complex number is given, then find the conjugate of 2 times, you will get the same complex number. Okay. Number 2, z bar equal to z. Z bar equal to z if z is purely real. The conjugate of a complex number is itself means that complex number must be a real number. Okay. If and only if z is a purely real. If and only if z is purely real. Okay. Or z bar equal to z if z is purely real. Number 3, z bar equal to minus z if z bar equal to minus z if z is purely imaginary. Because every imaginary number is a complex number. So if a complex number is purely imaginary, then z bar equal to minus z. If a complex number is purely real, then z bar equal to z. Okay. Then number 4 property, z plus z bar. Dekho, if we take a z equal to a plus ib, then what will be z bar? So z bar equal to a minus ib. So what is z plus z bar? So z plus z bar equal to a plus ib plus a minus ib. Plus ib minus ib cancel. This is 2a. 2a means real part of z. So z plus z bar equal to 2 into real part of z. 2 into real part of z. Number 5, z minus z bar equal to 2 into imaginary part of z. This proof is very easy. No. If we take z equal to a plus ib, then write z bar equal to a minus ib. Z minus z bar equal to a plus ib minus of a minus ib. So plus a minus a cancel. Ib minus a minus ib means plus ib. That is the 2 into imaginary part of z. And 6th number is z1 plus z2 the whole conjugate. Z1 plus z2 whole conjugate equal to z1 conjugate plus z2 conjugate. Or this property can be extended into any number of or sum of any number of complex number. If we take a 3 complex number, z1 plus z2 plus z3 the whole conjugate equal to z1 conjugate plus z2 conjugate plus z3 conjugate. Okay. Similarly, z1 minus z2 the whole conjugate equal to z1 conjugate minus z2 conjugate. This proof you can prove by taking z1 equal to a plus ib and z2 equal to c plus id. Okay. Now these are complex number negative proof kari pariyo. And 8th property, z1 into z2 the whole conjugate. z1 into z2 the whole conjugate equal to individual conjugate z1 conjugate into z2 conjugate. Next 9 number property, z1 by z2 the whole conjugate equal to z1 conjugate whole by z2 conjugate. Okay. So z1 by z2 whole conjugate equal to z1 conjugate by z2 conjugate. where z1 z2 is not equal to 0, z2 not equal to 0. Okay, these are the properties of the conjugate of the complex number. Okay, note alla z1 into z2 ର whole conjugate equal to z1 ର conjugate into z2 conjugate. If we take a z1 equal to z2 equal to z, जदि आम z1 जगह z पकेबा, ये आम जदि z पकेबा कौन अच्छी z into z ର conjugate हम, that is z into z ର conjugate equal to what, z ର conjugate into z ର conjugate है. But z into z means what, z square, this is the z square. तो z square conjugate equal to z conjugate ର whole square. So z square conjugate equal to z conjugate square. So in general z to the power n, z to the power n ର whole conjugate equal to z conjugate power n, z conjugate power n, where n belongs to capital N. Okay, so z to the power n ର conjugate equal to z conjugate whole power n. Okay, so you can prove all these properties by taking z1 equal to a plus ib and z2 equal to c plus id. z1 नब a plus ib, z2 नब c plus id नहीं तुम सब जाक प्रूव कर पारिबो. ओके, दैट इज so these are the extension properties z1 plus or minus z2 plus or minus z3 plus or minus dot 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 plus or minus z1 the whole conjugate equal to z1 the conjugate plus or minus z2 conjugate plus or minus zn the conjugate. Okay, so plus thile pura plus hobo, minus thile bi minus hobo, into multiplication thile bi multiplied hobo. Okay, now we prove one things, the z1 minus z2 the whole conjugate equal to, we prove z1 minus z2 conjugate equal to z1 minus conjugate minus z2 the conjugate. Proof, let z1 equal to a plus ib be a complex number and z2 equal to c plus id. Okay, now z1 minus z2 equal to a plus ib minus c plus id, and this is a plus ib minus c minus id. This is a minus c plus I into b minus d. So a minus c plus I into b minus d, this is the z1 minus z2. z1 minus z2 ro whole conjugate equal to a minus c plus I times b minus d ro whole conjugate. The real part is a minus c and the imaginary part is b minus d. So after taking conjugate, you take a opposite sign of the imaginary part, that is a minus c minus I into b minus id, and this is a minus c minus ib plus I minus minus plus I into d. Okay, so here a minus ib minus c plus id taking common, a minus ib minus common c minus id. Okay, and this is a minus ib means this is z1 the conjugate minus c minus id means z2 the conjugate. So z1 minus z2 the whole conjugate equal to z1 the conjugate minus z2 the conjugate. So proof is complete. In this way you have to prove all these properties of the conjugate of the complex number. Okay, now take it example, find the conjugate. For example, find conjugate of number 1 2 plus I rho whole square, 2 plus I rho whole square. Number 2 1 minus 3I by 1 plus 2I. Find the conjugate of this one. Number 3 1 plus I into IQ plus 1. Okay, into IQ plus 1 आंसर 1 देख यार कंजुगेट आम बाहर करवा लेट z इक्वल टू 2 प्लस आई रो स्क्वायर तो फास्ट यू हैव टू मेक a plus ib form then you have to find a conjugate or you can do by using property directly ना नहीं तुम a plus ib रे कन्वर्ट कला कंजुगेट ना हम बा प्रॉपर्टी यूज करी कले भी हो पार अच्छा z इक्वल टू 2 प्लस आई रो होल स्क्वायर मीन्स z रो कंजुगेट इक्वल टू 2 प्लस आई रो होल स्क्वायर रो कंजुगेट you know z square conjugate z square conjugate equal to z conjugate square this is the property and this is known as 2 plus I conjugate whole square okay 2 plus I conjugate square this is 2 minus I square here 4 plus I square minus 2ab a minus b whole square a square plus b square minus I square means this is I square a square plus b square minus 2ab minus 2 a means 2 b means minus I so 4 I square means minus 1 plus 4i so this is 3 plus 4i 3 plus 4i this is the conjugate of 2 plus I whole square और जब तुम डायरेक्ट करता तो 2 प्लस आई होल स्क्वायर फास्ट मेक करता तो a प्लस आई भी फॉर्म जानता तो कौन हम 4 प्लस आई स्क्वायर प्लस 4i आई स्क्वायर मीन्स माइनस 1 4 माइनस 1 के हम 3 प्लस 4i 3 प्लस 4i कंजुगेट कौन हम सॉरी 3 4 माइनस 1 है नहीं कि अच्छा आर कंजुगेट आसो 2 प्लस आई होल स्क्वायर सो दिस इज I square means minus 1 right 4 minus 1 3 plus 4i so 3 plus 4i the conjugate so what happened this is okay so it the conjugate is 4 plus I square plus 4i है so 4 I square means minus 1 4 minus 1 कहते 3 plus 4i नहीं कि 3 plus 4i रो conjugate कौन हम 3 minus 4i हम एटी टिके हमर मिस्टेक अछि एटा a minus b whole square a square plus b square minus 2a a means 2 b means कौन पड़ियो I पड़ियो ना टी कहीं एटी हमें b एटी a minus b फॉर्मूला यूज करछे ना सो b टा होची तमरो I हैला minus 2a b b means I so this is minus 4i means 3 minus 4i so 2 plus I 2 minus I square केते होची 3 minus 4i आ यार कंजुगेट आसियो केते आसियो 4 minus 1 माने 3 plus 4i 3 plus 4i रो कंजुगेट कोन हो 3 minus 4i ओके तो तुम प्रॉपर्टीज यूज करी कल हबो डायरेक्ट बा a plus ib फॉर्म में कन्वर्ट करी कल भी हे पारियो ओके यू कैन डू इन योर चॉइस नेक्स्ट नंबर 2 1 minus 3i by 1 plus 2i like that number 2 let z equal to 1 minus 3i by 1 plus 2i so z bar equal to 1 minus 3i by 1 plus 2i रो whole conjugate means this is 1 plus 3i by 1 minus 2i this is not in a plus ib form to make a plus ib form so in order to a plus ib form first we multiply conjugate of the denominator in the numerator and denominator okay तो हमें डायरेक्ट कंजुगेट नहीं गले एट 1 plus 3i into 1 minus 2i है तो ये हमें कौन करा 1 plus 3i एट 1 plus 2i by 1 minus 2i into 1 plus 2i जेहेतु डिनोमिनेटर 1 minus 2i अच्छी 1 plus 2i ऊपर मल्टीप्लाई कर दो तले मल्टीप्लाई कर दो तो आपको मल्टीप्लाई कले कौन आसो दिस इज 1 plus 2i 1 plus 2i plus 3i plus 6i square whole by a plus b into a minus b a square minus b square 1 square minus 2i square so 1 I square means minus 1 plus 5i minus 6 by 1 minus 2 okay minus 2 into I square means minus 1 sorry 2 square है 4 है so this is 1 minus 6 minus 5 plus 5i by 1 minus 4 5 है and this is minus 5 by minus 5 minus 1 plus I minus 1 plus I This is the conjugate z bar equal to minus 1 plus I. और तुम यहाँ को फास्ट ए प्लस आई बी फॉर्म कन्वर्ट कला तार कंजुगेट बाहर कले भी हम. सिमिलरली यू कैन डू थर्ड नंबर ऑल्सो. ओके, by using properties or by first to make a plus ib form, then to find its z form. One question: if a plus I whole square by 2a minus I equal to p plus iq, then show that p square plus q square equal to a square plus 1 plus a square plus 1 whole square by 4a square plus 1. Okay, so how can you prove that? Here we prove by taking conjugate, by using conjugate. Okay, answer देखो, given that p plus iq equal to a plus I whole square by 2a minus I, let it be equation 1. By taking conjugate on both sides, कहीं हमको p square plus q square आने पड़ो. Taking conjugate on both sides, taking conjugate both sides, that is p plus iq रो whole conjugate equal to a plus I रो whole square by 2a minus I रो whole conjugate. That implied p plus iq conjugate means p minus iq. A plus I रो whole square conjugate means this is a plus I रो square रो conjugate by 2a minus I रो conjugate z1 by z2 रो whole conjugate equal to z1 रो conjugate by z2 conjugate, and this is a plus I रो square रो conjugate. This is known as a plus I रो conjugate रो square by 2a minus I रो whole conjugate. So a minus I रो conjugate means this is a minus I रो whole square by 2a plus I, let it be equation 2. So in equation 1 p plus iq left hand side, in equation 2 p minus iq, it p plus iq ଅଛି, it p minus iq ଅଛି. In order to get a p square plus q square, now multiplying 1 and 2, multiplying equation 1 and 2, multiply equation 1 and 2 on corresponding side, we get p plus iq into p minus iq equal to here a plus I रो whole square by 2a minus I multiplied a minus I रो whole square by 2a plus I. Now a plus I रो whole square into a minus I रो whole square means this is a plus I into a minus I रो whole square by 2a minus I into 2a plus I. Okay, a plus b into a minus b, this is a square minus b square, this is known as a square minus I square रो whole square by 2a minus I into 2a plus I, this is 2a रो square means 4a square minus I square. Okay, but I square means minus 1, so this is a square plus 1 रो whole square by 4a square plus 1. So a square plus 1 रो whole square by 4a square plus 1, and this is RHS part. This is known as RHS part. Okay. So a square plus 1 रो whole square by 4a square plus 1, this is RHS part. Okay. Next we do another question. If x plus iy equal to root over a plus ib by c plus id, then prove that x square plus y square whole square equal to a square plus b square by c square plus d square. Here also we prove in the same ways. Let it be equation 1 answer. Let x plus iy equal to root over a plus ib by c plus id. Let it be equation 1. So by taking conjugate, that is So taking conjugate on both sides, conjugate x plus iy the conjugate equal to root of a plus ib by c plus id the whole conjugate, okay, and x plus iy the conjugate means this is x minus iy. So a plus ib by c plus id the whole conjugate means root of a plus ib conjugate means this is a minus ib by c minus id. ना नहीं कहेंगे z स्क्वायर और z टू द पावर n रो conjugate और z रो conjugate रो n equal to z रो conjugate रो n, okay. So that is z to the power n, z to the power n रो conjugate, z to the power n रो whole conjugate equal to z रो conjugate रो power n, like that, okay. And let it be equation 2. Now multiplying equation 1 and 2, we get multiplying equation 1 and 2 equation 1 into equation 2, that implied x plus iy into x minus iy equal to root of a plus ib by c plus id into root of a minus ib by c minus id, okay. Now x plus iy into x minus iy, that implied x square minus I square y square means this is y square equal to square root a plus ib into a minus ib, this is a square plus b square by c square plus d square. Now squaring on both sides, so x square plus y square whole square equal to a square plus b square by c square plus d square. So this proof is complete and this is proof. So x square plus y square whole square equal to a square plus b square by c square plus d square, okay. So here by taking conjugate to prove. Next we do another problem also. So find real theta such that 3 plus 2i sin theta by 1 minus 2i sin theta is purely real. You know a complex number z is purely real if z bar equal to z, no? Or you can take also, first you have to convert the given complex number into a plus ib form. Purely real means take imagined part is equal to 0. तो प्रथमे आपको ए जो कॉम्प्लेक्स नंबरटा अच्छी आपको ए प्लस आई बी फॉर्म रे कन्वर्ट करिवो, कन्वर्ट कला परे तार इमेजिन पार्टटा जतिकी थिबो ताको इक्वल टू 0 करिगिरी तमे थीटा रो वैल्यू सॉल्व करि पारियो, और बाय यूजिंग द फॉर्म बाय यूजिंग प्रॉपर्टी ऑफ द कंजुगेट कॉम्प्लेक्स नंबर इज z is purely real means z bar equal to z, okay. Answer, let z equal to 3 plus 2i sin theta whole by 1 minus 2i sin theta. So purely real, since z is purely real, so z bar equal to z, okay. That implied z bar means 3 plus 2i sin theta by 1 minus 2i sin theta the whole conjugate equal to z. Z means 3 plus 2i sin theta whole by 1 minus 2i sin theta, okay. So its conjugate means न्यूमरेटर कंजुगेट बाय डिनोमिनेटर कंजुगेट, यार कंजुगेट कौन हम 3 minus 2i sin theta हम, डिनोमिनेटर कंजुगेट कौन हम 1 plus 2i sin theta हम होल बाय 3 plus 2i sin theta by 1 minus 2i sin theta, okay. Now क्रॉस मल्टीप्लिकेशन या को आम कौन करवा, तो क्रॉस मल्टीप्लिकेशन कर दियो है। अच्छा आर क्रॉस मल्टिप्लिकेशन कले कौन हो 3 माइनस 2i sin थीटा इंटू 1 माइनस 2i sin थीटा बाय इक्वल टू 3 प्लस 2i sin थीटा होल इंटू 1 प्लस 2i sin थीटा 1 plus 2i sin theta. Okay. Now 3 1 3 minus 6i 3 minus 6i sin theta minus 2i sin theta here minus minus a plus 4 into I square sin square theta 4 I square sin square theta equal to 3 plus 6i sin theta plus 2i sin theta plus 4i square sin square theta 4i square sin square theta. Okay, that implied 3 minus 8i sin theta I square means minus 1 so minus 4 sin square theta and this is equal to 3 plus 8i sin theta 3 plus 8i sin theta I square minus minus 1 so minus 4 sin square theta minus 4 sin square theta. Okay, here देखो एडी 3 अच्छी एडी 3 अच्छी minus 4 sin square theta minus 4 sin square theta cancel है तो minus 8 sin theta plus 8i sin theta that implied minus 8i sin theta एटा left one minus 8i sin theta equal to 0 that implied minus 16i sin theta equal to 0. Okay, so 16i never be 0 that implies sin theta equal to 0 that implied sin theta equal to 0. So you know sin theta equal to 0 what is the general solution of sin theta equal to 0 in the trigonometrical equation you know sin theta equal to 0 means theta equal to n pi for all n belongs to z set. So these are the real solution for theta is equal to n pi. Okay, so in this way you have to calculate real values of theta or first तुम आपको a plus ib फॉर्म में ट्रांसफर करता तो a plus ib फॉर्म में ट्रांसफर कला परे since z is a purely real means तार इमेजिन पार्ट जेते थु ताको इक्वल टू 0 करी भी सॉल्व कर पारियो. ओके, नेक्स्ट we do another problem that is express the following into a plus ib form. Number 1 1 by 1 minus cos theta plus 2i sin theta. Number 2 1 by 1 minus 2i plus 3 by 1 plus I whole into 3 plus 4i by 2 minus 4i. Okay, so how to make into a plus ib form? Now answer 1. First you take z, let z equal to 1 by 1 minus cos theta plus 2i sin theta. Okay, so हमको rationalization करिया पड़ियो. To make a rationalization form, multiply the conjugate of a denominator in the numerator and a denominator. So 1 into 1 minus cos theta minus 2i sin theta, okay, whole by 1 minus cos theta plus 2i sin theta whole into 1 minus cos theta minus 2i sin theta. Okay, now this is 1 minus cos theta minus 2i sin theta divided by here a plus b into a minus b. एति तुम भाभी दियो a एटा होची b, this is a and b. तो a minus b into a plus b, this is a square minus b square. तो 1 minus cos theta whole square minus b square. तो b square means 2i sin theta whole square, a square minus b square, and this is 1 minus cos theta minus 2i sin theta whole by 1 minus cos theta whole square means 1 plus cos square theta minus 2 cos theta plus 4 I square means minus 1 तो minus of minus 1 plus 1 4 sin square theta. Okay, now this is 1 minus cos theta by 1 minus cos theta by here cos square theta plus sin square theta. So this is एटी आम कौन करवा माइनस 2i sin theta by 1 plus cos square theta plus 4 sin square theta means you split this one. 4 sin square theta means sin square theta plus 3 sin square theta, but cos square theta plus sin square theta लिख दियो cos square theta plus sin square theta plus 3 sin square theta एम स्प्लिट कर दबो एटा को 4 sin square theta को and minus 2 cos theta, and this is 1 minus cos theta minus 2i sin theta whole by cos square theta plus sin square theta 1 है 1 plus 1 के 2 है 2 plus 3 sin square theta minus 2 cos theta okay, and this is equal to 1 minus cos theta minus 2i sin theta whole by 2 common है कौन होती 1 minus cos theta plus 3 sin square theta okay, and this one can be expressed 1 minus cos theta by 2 into 1 minus cos theta plus 3 sin square theta 3 sin square theta plus I into minus 2 sin theta by okay 2 into 1 minus cos theta plus 3 sin square theta okay, which is a plus ib form, which is a plus ib form. This is the real part and this is known as the imaginary part okay. So similarly you can do in second number first bracket ता तमे simplify करियो तो first bracket ता simplify करला पोरे है ना first bracket ता simplify करियो जा आसीबो second bracket सहित multiply करियो okay, then देखो second one हम सो फास्ट ब्रैकेट को सिंप्लीफाई करियो तापर सेकंड ब्रैकेट सहित मल्टीप्लाई करियो ना कि तो मल्टीप्लाई कला पर रेशनलाइजेशन करी बाहर करियो दिस क्वेश्चन इज योरसेल्फ यू कैन डू दिस क्वेश्चन नंबर 1 फाइंड रियल थीटा फॉर व्हिच द कॉम्प्लेक्स नंबर 1 plus I cos theta by 2 by 1 minus 2I cos theta is purely real. So this complex number is purely real. What will be the value of theta? तो प्योरली रियल मीन्स यू नो z बार इक्वल टू z ना नहीं. नंबर 2 फाइंड द मल्टीप्लिकेटिव इनवर्स ऑफ द कॉम्प्लेक्स नंबर. मल्टीप्लिकेटिव इनवर्स केमती बार कराल फास्ट वी टेक लेट z इक्वल टू √5 plus 3i देन z इनवर्स इक्वल टू 1 by z आपको रेशनलाइजेशन करी बाहर करियो ना कि सेम थर्ड नंबरटा भी z1 इज 2 minus i z2 minus 2 plus i फाइंड रियल पार्ट ऑफ z1 into z2 by z1 रो कंजुगेट. तो z1 into z2 by z1 रो कंजुगेट बाहर करियो तापर तुम रियल पार्ट बाहर करियो. नेक्स्ट फाइंड x and y इफ 3x minus 2iy plus 2 plus i रो होल स्क्वायर इक्वल टू 10 into 1 plus i. देखो राइट साइड 10 into 1 plus i मीन्स आर a plus ib फॉर्मटा कौन 10 plus 10i तार रियल पार्ट 10 है इमेजिन पार्ट 10 अच्छे किंतु एडी a plus ib फॉर्म अच्छे कि ना तो फास्ट 2 plus i रो होल स्क्वायर को एक्सपांड करिवो या सहित मल्टीप्लाई करियो मल्टीप्लाई कला पर सेटा a plus ib फॉर्म आसियो a plus ib फॉर्म आइला पर ताकू रियल इक्वटिंग रियल एंड इमेजिन पार्ट करी बाहर करियो. सिमली 1 plus i into x minus 2i plus by 3 plus i एमदी अछि तो एटा भी a plus ib फॉर्म नाइ आको फास्ट a plus ib फॉर्म ट्रांसफर करिया पड़ियो ना कि a plus ib फॉर्म ट्रांसफर करिया बोले एटा को सिंपलीफाई करिया पड़ियो फास्ट एलसीएम नबो एलसीएम नहीं करिया पड़ियो किंतु एलसीएम नेबा पूर्व एटा को प्रथम a plus ib फॉर्म रखियो. एटार a plus ib फॉर्म देखो x plus i into x अछि ना एटा कोन होला x plus ix minus 2i by 3 plus i plus सेम दीटा मल्टीप्लाई कर दियो 2y minus 3yi plus i by 3 minus i equal to i ला. तो एटी केमती लिखियो ना x plus x minus 2 into i एमती लिखियो एटा को by 3 plus i plus एटी कौन करियो 2y plus 2y plus 1 minus 3y into I है 2y plus 1 minus 3y into I by 3 minus I equal to I तापर कौन करियो एबे तुम एडी एलसीएम नबो एडी डायरेक्ट एलसीएम नबो नाही एडी डायरेक्ट एलसीएम नै कले कॉम्प्लिकेटेड हबो तो प्रथम एटा को a plus ib फॉर्म लिखिलो ए पार्टा को a plus ib फॉर्म लिखियो एडी एबे एलसीएम नबो हर हरि लबरे गुणियो ना नहीं तापर इक्वेटिंग करियो इक्वेटिंग कले ए स्टेप रे इजी हबो किंतु ए स्टेप रे इजी हबो नाही ओके रिमेंबर दिस वन डू यू अंडरस्टैंड नेक्स्ट क्वेश्चन है 5 नंबर टा हियर a plus ib गिवन अछि to prove that a square plus b square equal to x square plus 1 whole square by 2x square plus 1 whole square. So you do all this problem. In next class we do modulus of the complex number and the properties and different form of the complex number. Thank you.